Several alternative motor starting methods exist. Firstly, consider a star-delta starter. This type of starter switches the motor connections from a star configuration to a delta configuration. By doing so, it reduces the starting current by a factor of approximately 3. However, it is essential to acknowledge that this method might necessitate additional equipment and wiring to implement successfully. Secondly, a part-winding starter can be utilized. This starter operates by initially connecting only a portion of the motor windings. Then, it gradually brings the remainder of the windings online. This staged approach effectively reduces the starting current drawn by the motor. Thirdly, explore the use of a variable frequency drive, often referred to as a VFD. A VFD offers a sophisticated approach to motor starting by controlling the frequency and voltage supplied to the motor. This precise control enables a smooth and gradual start, allowing the motor to increase speed progressively. VFD offer benefits beyond just motor starting, including speed control capabilities and potential for reduced energy consumption, making them a versatile solution. Turning to power factor considerations, using a Baldo soft starter may experience a slight impact on its power factor when the second motor starts using an across-the-line starter. This impact arises because the across-the-line starter inherently draws a higher inrush current compared to a soft starter. This sudden surge of current can cause a momentary voltage drop within the electrical system. To mitigate the potential negative impact on the power factor, several measures can be taken. Firstly, ensure that the generator has sufficient capacity to handle the combined starting currents of both motors. A generator with adequate capacity will be able to supply the necessary power without experiencing significant voltage drops. Secondly, implement a time delay relay in the motor starting sequence. This relay will prevent the second motor from starting immediately after the first motor is initiated. By staggering the starts, the peak inrush current demand on the generator is reduced. Thirdly, consider installing a power factor correction capacitor. This capacitor can be installed either at the generator terminals or at the motor terminals. Its purpose is to improve the power factor by compensating for the reactive power drawn by the motors. The soft starter for the first motor helps reduce mechanical stress on equipment, improving motor longevity. Also, regularly monitor and maintain the generator. Ensuring the generator can handle the load of both motors is important. If the generator is powered by a diesel engine, increase the engine speed during motor starting to compensate for the additional load. Regular monitoring and maintenance of the generator are essential to ensure its reliable operation. A proactive maintenance schedule can identify and address any potential issues before they escalate into major problems. Ensuring that the generator has adequate capacity to handle the combined starting currents of both motors is a crucial step in preventing voltage drops and maintaining a stable power supply. This involves carefully evaluating the generator's specifications and comparing them to the expected load requirements of the motors. Implementing a time delay relay to stagger the starting of the two motors can significantly reduce the peak inrush current demand on the generator. This staggered approach allows the generator to gradually ramp up the power supply, minimizing the stress on the system. Installing a power factor correction capacitor is another effective measure to improve the power factor and compensate for the reactive power drawn by the motors. This capacitor helps to reduce the overall current demand on the generator, leading to improved efficiency and stability. The use of a soft starter for the first motor is highly recommended as it helps to reduce mechanical stress on the equipment and improve the motor's overall longevity. Soft starters provide a gradual and controlled start, minimizing the sudden jolts and vibrations that can damage the motor and connected machinery. The generator should be regularly monitored and maintained to ensure that it can effectively handle the load of both motors. This includes checking the generator's voltage, current, and frequency to ensure they are within acceptable ranges. It also involves inspecting the generator's components for any signs of wear or damage. If the generator is powered by a diesel engine, it may be necessary to run the engine at a higher speed during motor starting to compensate for the additional load. This helps to maintain the generator's voltage and frequency within acceptable limits. In summary, several alternative motor starting methods are available, each with its own advantages and disadvantages. When selecting a motor starting method, it is important to consider the specific requirements of the application, including the motor size, load characteristics, and available power supply. Power factor is an important consideration when starting motors, as a low power factor can lead to increased energy consumption and reduced system efficiency. By taking steps to improve the power factor, such as installing power factor correction capacitors, it is possible to reduce energy costs and improve the overall performance of the electrical system. Regular monitoring and maintenance of the generator are essential to ensure its reliable operation and prevent any potential issues. A proactive maintenance schedule can help to identify and address any problems before they escalate into major breakdowns. By following these guidelines, it is possible to ensure the smooth and efficient starting of motors while minimizing the impact on the electrical system and maximizing its overall performance. Furthermore, selecting the most appropriate motor starting method involves considering not only the immediate electrical impact but also the long-term mechanical effects on the connected equipment. Soft starters, for instance, offer the advantage of reducing mechanical stress, which can extend the lifespan of both the motor and the driven machinery. Star-delta starters, while effective in reducing starting current, may introduce torque transients that could potentially stress mechanical components. VFD provide the most comprehensive control over motor starting and operation, allowing for precise adjustments to acceleration and deceleration rates, minimizing mechanical shock and optimizing energy consumption. Beyond the starting phase, the operational characteristics of the motors and the generators should be carefully considered. Harmonics generated by nonlinear loads, such as VFD and some types of soft starters, can negatively impact the generator's performance and lifespan. Implementing harmonic filters or selecting equipment with built-in harmonic mitigation features can help to minimize these effects. Monitoring the generator's output voltage and current waveforms can provide valuable insights into the presence and magnitude of harmonics. The ambient temperature and altitude at which the motors and generator are operating can also influence their performance. Motors and generators are typically rated for specific operating conditions, and exceeding these limits can lead to dirting or even failure. Ensuring adequate ventilation and cooling can help to maintain optimal operating temperatures and prevent overheating. In high-altitude environments, the reduced air density can affect the motor's cooling capacity and may require dirting or the use of specialized high-altitude motors. The type of load being driven by the motors also plays a significant role in determining the appropriate motor starting method and the required generator capacity. Loads with high inertia, such as flywheels, require more energy to start and accelerate, placing a greater demand on the generator. In such cases, a soft starter or VFD may be particularly advantageous, as they can provide a controlled and gradual acceleration, minimizing the peak current demand on the generator. Loads with variable torque requirements, such as crushers, may benefit from the speed control capabilities offered by VFD, allowing for optimization of energy consumption and process efficiency. Regular inspections of the motors and generators' insulation are crucial for preventing electrical breakdowns. Insulation degradation can occur due to factors such as overheating, moisture, and contamination. Performing insulation resistance tests, such as mega tests, can help to identify insulation weaknesses before they lead to catastrophic failures. Implementing a preventative maintenance program that includes regular cleaning, lubrication, and tightening of connections can also help to extend the lifespan of the motors and generator. Furthermore, ensuring proper grounding of the motors, generator, and associated equipment is essential for safety and for preventing electrical noise from interfering with sensitive electronic devices. A properly grounded system provides a low impedance path for fault currents, minimizing the risk of electric shock and equipment damage. Regularly inspecting and testing the grounding system is crucial for maintaining its effectiveness. Finally, consulting with qualified electrical engineers and technicians is highly recommended when designing, installing, and maintaining motor starting systems and generators. These professionals have the expertise and experience to ensure that the system is safe, reliable, and optimized for its specific application. They can also provide valuable guidance on selecting the appropriate equipment, implementing preventative maintenance programs, and troubleshooting any issues that may arise.